Hello everyone, I'm Benoit, and we will present at today with Christophe, and we are both research associate at University Laval, in charge of the Source to Sing project. So today we are going to present some results and updates related to our project, but before to do that, we will reintroduce our general project, which is the Source to Sing project. So all of the projects deal with the understanding of the Auriferous fluid flow system active in deformation zones and at the origin of orogenic gold deposits. And here is the Source to Sing team, composed of most of the professors from the department, of PhD and MSc students, of one postdoc, and of 2 research associates. So these different projects are the results of collaboration with industrial partners, mainly from ABTB, and with academic collaborators from France and from Quebec. And all of projects deal with the understanding of parameters that control gold endowment. And more specifically, we try to determine what are the source of fluids and volatile. And volatile by determining what are the geological processes driving fluid release and what are the lithologies the fluids are derived from. On another hand, we try to determine if spatial variation of fluid flow mimic the irregular distribution of gold mineralization. In other words, what are the fluid flow conditions to form a deposit? And finally, we also focus our work on the timing of gold mineralization using the geochronology of accessory minerals in veins in order to determine the time frame of hydrothermal fluid events. So here are our strategies to compare endowed and less endowed area at different scale. At superior scale, for example, by comparing the ABTB end member, endowed end member, to the Wabigoon less endowed end member. And we also do that at transect scale and deposit scale. So here are the different projects of our team. All of the students will present their work during this partner meeting. Yasaman talked of her project during the first day, dedicating more specifically to the geophysics projects. And Guillaume, Isaac, and Michael will present their work just after us this afternoon. So now let's move on the project we are working on with Christophe, the regional isotopic survey systematic. The idea of this project is to compare the stable isotopic composition of minerals and fluids at various scales between endowed and less endowed area in order to determine what are the fluid flow conditions to form an orogenic gold deposit. In the worldwide database, we compiled stable isotope composition of vein minerals associated to orogenic deposit from the literature. At the superior scale, we also built a stable isotope database, including data from the literature and data from samples collected along the transects. And finally, we also focus our work on specific deformation zones in order to perform detailed study of spatial variation of fluid flow, and for example, in the Molly-Degagné deformation zone, and more recently along the Cadillac-Larder Lake deformation zone. So, as I said, the idea of this project is to determine if scale of observation matters. In other words, are fluids, sources, processes, fluid flow conditions comparable at various scales between endowed and less endowed area. And at each scale, we determine the variability of isotopic mineral and fluid composition, as well as temperature of formation of the vein as function of various parameters, such as the location of the deposit or the nature of the earthquake, etc. So what can we learn from the worldwide compilation? I will only focus on the fluid composition for this part of presentation. About the source of fluid, results are equivocal, but likely suggesting a metamorphic origin for the deep-seated fluid, even if a significant number of data are in the shared magmatic metamorphic field. About the sink, we document very homogeneous temperature formation around 360 degrees, and we also document evidences of fluid mixing between a deep crustal reservoir and an upper crustal reservoir. We also document isotopic fluid buffering, depending on the nature of the host rock in which the deposits are located. And what we show is that when hosted in sedimentary derived rocks, orogenic fluids and minerals are enriched in O18. So these observations are not correlated to the age or the location of the deposits, suggesting that there are no significant differences of fluid flow conditions through time and space at a worldwide scale. At the superior scale, we compare the composition of fluids that have circulated in various deformation zones in various provinces. We do not document specific differences between subprovinces, but we identify interesting features. As for the worldwide orogenic gold deposit database, we document fluid mixing between an upper crustal fluid reservoir and a deep crustal fluid reservoir. And as shown on this diagram, the deep crustal fluids are likely metamorphic in origin, whereas the upper crustal fluids could be modified seawater. We also document isotopic fluid buffering, depending on the nature of the host rock. The fluid having the highest delta weighting values are commonly documented for veins hosted in sedimentary derived rocks, as it is the case for the Wawa subprovince, for example. In terms of temperature, they are comparable between subprovinces around 380 degrees. And finally, better documented that for the worldwide database, we see that the numerous data plot above the field of metamorphic water with very positive hydrogen isotope composition. And finally, it is very difficult to realize this data to natural water reservoir. And we suggest that successive boiling condensation cycles related to the fall valve system is likely the process at the origin of such enrichment in deuterium. Now, what can we learn by comparing two variably endowed deformation zones from ABTB? So here are the specificities of both areas. The Molly-Degani area, no gold endowment documented. Structure, alteration, and metamorphism are consistent with an orogenic system. We found mostly quartz tourmaline veins. This is a small deformation zones and a small sampling area. And on another hand, we have Valdor area, which is a highly endowed area. This is a well-known orogenic system with quartz carbonate or quartz tourmaline carbonate veins along a large deformation zone, which is a ladder-like Cadillac deformation zones, and it's a large sampling area. For both areas, we document comparable temperature of formation, as well very comparable isotopic composition of fluids. Indeed, as you can see just here, the fluids from both areas fully overlap. We also document fluid mixing between metamorphic fluids and upper crystal fluid, which is likely modified seawater. And finally, we also document for both areas numerous data above the field of metamorphic water with very positive hydrogen isotopic composition. And as I said, we suggest that this atypical value reflect fluid having experienced successive boiling condensation cycles. So to test this hypothesis, we perform isotopic modeling using different scenarios of boiling condensation cycles. And the fact is that we have a really good overlap between the model and the data for under isothermal condition with evaporation between 10 and 40% for each step of boiling condensation. So now I let Christophe present the result of the spatial analysis we did along the Cadillac ladder-like deformation zone.
So yeah, hi everyone. Now we will specially zoom in on the Cadillac ladder-like deformation zone. This project aims to document the oxygen 18 and deuterium variation of orogenic veins that consist mainly on quartz, tourmaline, chlorite, and carbonate veins along the Cadillac ladder-like deformation zone between the Rwanda and Valdor field. This work is based firstly on a compilation of data from literature, where 291 data have been compiled. We also added the data set from the master thesis of Guillaume Raymond. Guillaume will present you his result just after his presentation. And within the method of project, we also provide 259 data, which apart come from collaboration with Tos and Chiao that work along the Rwanda and the Malarctic transect respectively. So the strategy used was to document the variation of the three main data, the oxygen and deuterium signature of minerals that constitute the orogenic vein. Secondly, the estimated temperature based on isotopic equilibrium between two-phase minerals in the same isotopic system. And thirdly, the oxygen and hydrogen signature of the recalculated water. The variation of this dataset have been investigated according to 4 different parameters, namely the position along the different segments forming the cardiac ladder lake deformation zone, the distance from the break, the nature of the host rock, and the depth of the orogenic sample. Now, if you look the variation of the O18 signature of the quartz regarding the position along the cardiac ladder lake deformation zone, we document that the western part, which correspond to the dataset between Rouen and Beaupré, is significantly enriched compared to the dataset in the western part between Hallet and the Val d'Or area. The O18 value from Val d'Or and Hallet are mainly comprised between 9 and 13 per mil, whereas the oxygen value from the western segment and mainly between 12 and 16. Actually, the interpolation of O18 value of quartz by Quijing allow to report this west-east anisotropy, but also allow to identify a north-south isotopy where veins that are within the cardiac ladder lake fault are seems to be characterized by higher O18 values compared to the data that are above the break. So the question that we want to address here is, are these variations related to temperature variation or to fluid itself? If we now focus on temperature estimates, the first important thing is that most of mineral spare are in isotopic equilibrium, as shown the distribution along the 250 and 550 degrees isotherms. The second important thing is that there is no variation regarding the different segments. All orogenic veins are mainly formed between 300 and 400 degrees. So the O18 variation observed between Rouen and Val d'Or is more likely related to variation of fluid composition. So here is the variation of the O18 value of calculated water according to the distance from the break and depending of the nature of the host rocks. The two main lithology that are host orogenic gold deposit are sedimentary in gray and mafic to intermediate metavolcanics in green square. Firstly, we see that the higher O18 values are mostly documented in sedimentary rocks, as Benoit said just before, and they are mainly enclosed within the cardiac lake deformation zone. Secondly, we document a decrease of oxygen 18 with the distance from the break. This decrease is mainly observed within the same lithology, namely the mafic to intermediate metavolcanic rocks. And so this decrease cannot be explained by the impact of the change of the hosting rocks and suggests that is mostly related to a competition between at least two main fluid reservoirs with different O18 signature, high O18 signature within the break and a low O18 fluid when we are away from the fault. More information can be distinguished if you look the variation of the deuterium signature of the water as function of the distance from the break. We observe firstly a large variation of the deuterium signature along the break between very low delta D values that are interpreted as the signature of the deep crystal fluid to medium signature interpreted as the signature of the upper crystal fluid, and as Benoit presented just before, the very high delta D values that are interpreted are related to phase separation in a boiling condensation cycle related to a fold valve system. But one important thing is that when we go away from the faults, data seems to evolve to 0. That indicate a progressive mixing with the upper crystal fluid away from the fault. So to conclude, we interpret the variation of the O18 signature along the break as the competition between the two main fluid reservoirs. So the first order cardiac Lauder Lake fault drive up the deep crystal fluid towards the upper crust, where they could interact with the upper crystal fluid and also undergone phase separation due to a fold valve system. And away from the first order break, when we go towards the second and third order faults, the deep crystal fluid is more and more diluted within the upper crystal fluid. So to finish, the worldwide compilation on stable isotope of orogenic gold deposits have been just recently accepted for publication with moderate revision. At least three other articles are soon to be submitted in first order international publication. And they concern work that have been done in Laval University, but also work collaboration with other Metal Earth teams. The next step, the next few months will be dedicated to doing the similar exercise that we performed on the spatial variation on O18 between Noranda and Val-d'Or, but around the Geraldton area. So fieldwork was completed this summer, and analyses are in progress. In the same way, we currently deal with a worldwork sample that we receive from Georgi to decipher fluid rocks interaction leading to alteration around the Lauder Lake. Yeah, thank you.
Great, thank you very much, Benoit and Christophe. We have some time for a couple questions. Question: how do you minimize the effect of having different host rocks on these veins?
Oh, we minimize them.
Well, you're measuring mainly quartz veins, eh?
Yeah.
But they have a variety of host rocks.
Yeah, so when we sample a vein, we just document what is the nature of the host rock, and we can. The only thing we can do is to determine. We document variation of the mineral composition of the quartz composition as function of the nature of the host rock. But we can. I'm not sure to have well understood your question, Maurice.
Well, the fluids are going to interact with the host rock. You know, we know that because the host rocks are extensively altered.
Yeah.
And when they do that, they will exchange, and their oxygen isotopic composition will vary with the host rock. Yeah. And is there any effort to be able to try to normalize it or minimize it or calculate what that exchange could be, or is it just such a fluid-dominated system it doesn't make any difference?
No, we don't have a way to quantify the intensity of the interaction with host rock. We did that with the project of Guillaume Raymond along the Augmito segment in Rwanda, and we didn't find a lot of differences between the well-endowed and less endowed area, and we didn't find a link to the intensity of the alteration of the host rock. So we done that we did that on specific cases, but for the compilation at large scale, we didn't do that because we need to perform detailed study to be able to quantify this effect.
Okay. All right. Well, thank you very much.